Hello and welcome back to another CS Lightwork video. Today I'm bringing you guys the bubble sort algorithm in Java. Now in this video we'll be going through the functionality quickly and the syntax of the bubble sort in the Java programming language. If you guys are looking for an in-depth explanation or are unsure of the full functionality of why we use bubble sort, how bubble sort works, and what bubble sort is for, feel free to click the video at the top of the description or in the top right corner for my full explanation on bubble sort. But here we're just going to be going through a quick synopsis of the functionality in Java, the differences between that and what you might have seen in Python, and the syntax. So without further ado, let's get into the video. Now, first and foremost, I'm just going to have this main function right here. It might look a little complicated, but essentially here we just have a test array of numbers that we're going to pass to our function, and then we have the array printing out twice, once before it's sorted and once after, and that's just so I can show you guys the algorithm at work. This isn't actually part of the bubble sort code itself. Now, like in the other languages, bubble sort in Java will be taking a list or an array of numbers. So as you can see, I have the function up here, and we have our test numbers right over here. So one of the key differences in bubble sort for Java or programming language like C is we don't have a function to just swap two elements in an array. So we need to use something called a placeholder, which I will showcase while we write it. So I'll just declare this placeholder right here. Now, a second key difference is, contrary to what you might have seen in Python, where we're sorting while it's not sorted as a Boolean value, here we're sorting the array until we've sorted it through the amount of times that is the size of the array. So what that means is if there's 5 numbers, we're going to run that sorting through the array 5 times. And this is because every time you perform a sort, one iteration, you guarantee, if you're going least to greatest, that the greatest number will be brought to the end. This is because, say you have an array here, it's just like this one, so the logic of the bubble sort will compare the two. If it needs to be switch, and compare the two and continue on. So the highest number will be brought to the end. So then you only need to iterate through the rest, and then the rest, and so forth. So you only iterate through the amount of times that there are numbers. So in this case, it would be 1, 2, 3, 4, 5, 6. All right, now that we got that out of the way, I'll get into the syntax, and what I'm saying will make a little more sense. Feel free to ask any questions if I'm going too fast or there's any confusions. Now what I want to do here is I want to declare an integer just holding the length of the array, so it's easier to loop through. So we'll just declare this int len, and we'll say this is numbers, which is the past array dot length. So that'll give us the length in Java. And now we can get in to our iterations. So first we're going to create this loop that is going through the array the amount of times we need to for the sorting. So in this case, it would be the length of the array itself. So what we're going to do here is we're going to create a for loop, and we're just going to say for int equals I. This is GitHub Autopilot. Again, if you guys aren't familiar, phenomenal application. As you can see, it knows exactly what I'm going to type. And essentially, we're just creating a for loop to increment through the entire array, and then within that, what we're going to do is we're going to have a nested for loop in here, and this is where we're going to put the functionality to actually loop through the list once. So here right now we're setting this so that we're going to go through the array of numbers, and excuse me for using list and array interchangeably, I mean the same thing. So here we're looping through it the amount of times there are elements, and then now we're going to actually loop through the list singularly. So again, let's have another variable, let's call it x, and we'll say x equals 0, and we want to set it so we're looping through until x is the length of the array minus 1. And remember, this is because we are comparing a value in the list and the value ahead. So we have to stop at the value before the end, or else we'll be at 1 and we'll be looking for a non-existent place. And in Java, that will just cause an error, unlike some coding languages where it might go to the first index. So as you can see, now we just make this loop, and voila, now we have the loop that we need to go through the comparison. And here's where it gets a little simpler. All we have to do is say, hey, if the number we're at, so we're going to say numbers x is bigger than the one next to it, the number ahead, so x plus 1, we're going to swap them. So how do you perform this swap? This is what's a little unique to C in Java and languages like this. You can't just have a one line function that's going to perform the swap. So this is where we use placeholder. So I want you guys to picture this in your head very vividly. So let's say we're looking at 64 and 32. And the reason I picked these is because this is something we need to swap. So 64 and 32. Our x is 64 and the number ahead is 32. Now we want to swap them, but the problem is if I set the number ahead to 64, it'll be 64, 64, we lost 32. So we need to save that number, either the number ahead or the number behind, in a placeholder so we don't lose it. So in this example, what we're going to do is we're going to store the first value, which is 64, in a placeholder instead of swapping it. So what we're doing is we're essentially setting the placeholder equal to number at the x index, which right now we're looking at 64 as an example. So now placeholder holds 64. And then what we can do is now set number x, which is the first index right here, to the next one. And this way we won't lose the 64 because it's right here. So now the list is 5, 32, 32, or the array is 5, 32, 32. And this is where we simply take the next index, which where it's 32 in the third spot, the second index, and set that to placeholder. And that way we have our swap completed. We don't need a function to swap them. We use a placeholder. And that's essentially the gist of the algorithm. Now, before we getting into compile this, you guys might have already noticed I've been using number instead of numbers. The amount of times I've made silly mistakes like these, I bet you guys can all relate. It would have saved me a lot of time. Now that we've changed that all, again, same functionality, just the variable name was wrong there. I'm going to open up my CMD and I'm just going to compile the code here. You guys can do this however you like. I'm just using Windows CMD, and then we're just going to run it. So as you could see now, we have the list before sorting and we have the list after sorting. Now, if you guys wanted to change this again to something like greatest to least, all we would have to do is look at that comparison we're doing and switch them. So instead of looking at, hey, is this bigger than the next? Is this smaller than the next? So we just do a little switch right there. And then as you could see, we're just going to save that, recompile it, and boom, now it's going from greatest to least. But that pretty much ends the video here. If you guys have any questions, please feel free to leave them down below. Again, like every video, I'm going to have this exact code file on the GitHub. Link's going to be at the top of the description. If I ran through too fast, you guys have any questions, any confusions, please feel free to let me know. But with that, thank you guys for watching. Take care.